Hi, welcome back. This video is about tension, and tension sometimes causes people some confusion, and really it's just a force that's exerted by a rope or a cable. The sum of the horizontal and vertical components of the tension are equal to 0 if the system is not accelerating. So for systems that are moving at a constant velocity, that would be a system that's not accelerating. Or the example that we're going to use here are for things that are hanging by a cable but not moving any place. Here's your multiple choice question. So right now we're going to find the tension in all three cables. And the first question is, well, what object am I drawing my free body diagram for? And the answer to that is the connecting point where the three cables connect. So this little ring, the ring right there, is where the object that we're drawing our free body diagram on. So let's go ahead and do that. Here's the ring. And cable number 3 is supporting the 15 kilogram block. I'm just going to label that m times g, the mass 15 times the acceleration of gravity. Cable number 1, I'll call that tension number 1. It's just a force. You could call force 1 if you wanted to. And then cable number 2. And let's go ahead and identify the angles. Well, let's see. For cable number 1, 45 degrees, which means that the angle down here is also 45 degrees. And then for cable number 2, the angle at the top there is 30 degrees. So the angle down here, the horizontal going through the ring, is also 30 degrees. I guess I'll clean that up so it looks more like a 1. And there we go. So our free body diagram is drawn. Now we need to sum our forces. Start by summing our forces in the x direction. Our box is not moving. It's not accelerating. So the sum of the forces are going to equal 0. That means our box is in equilibrium, which is what we hope. And so in the x direction, there are components of two forces that are pointing in the x direction. There's the x component of T1 that's pointing in the positive x direction, and then there's the x component of T2 that's pointing in the left or negative direction. So the x component of T1. So we would call that T1x. And it's adjacent to the 45 degree angle. So we would say that's T1 cosine of 45. And then T2. T2 is pointing to the left or the negative direction. T2 in the x direction would be T2 cosine of 30 degrees, but it's pointing left, so it's minus T2 cosine 30 degrees. Okay, so we have two unknowns in this one equation, so that tells me that we need to have a second equation. And we'll sum our forces in the y direction. That will give us our second equation, and hopefully through substitution we'll be able to solve this system of equations. So sum of the forces in the y direction is also equal to 0 because our system's not accelerating. And the y component of T1 is there. It's in the positive direction, it's pointing up. So that would be T1 sine of 45 plus T2, and the y component is T2 sine of 30 And then so our positive, we have T1 sine 45, and we also have T2 sine 30. So that's the forces that are pointing in the positive direction, minus whatever forces or components of forces are pointing in the negative direction, and that would just be mg. Okay, so I also have two unknowns in the y equation. The x equation is a little bit simpler because there's only two terms on the right-hand side, whereas in the y equation we have three terms. So what I'm going to do is I'm going to solve for t1 in terms of t2, and then substitute in to t1 in the y equation and solve it that way. Well, because this is equal to 0, I'm just going to move now that we have an equation for t1, we're going to substitute that directly in to t1 in the y equation. Okay, so our equation is written out with our substitutions in. I'm going to move mg to the left side of the equal sign. And then I'm going to factor t2 out of what's left over. Now it's a matter of dividing mg by everything that's on the right-hand side here, other than t2, and substituting in some numbers at that point. Okay, so what I'm going to do is I'm going to divide mg by the cosine sine terms, and that will leave us with a value for t2. And bringing up our handy calculator. That gives us 107.6 newtons. Okay, now we're ready to substitute into our equation for T1 to find out what that force is. So T1 is equal to T2, which is 107.6 times cosine of 30 divided by cosine of 45. And bring our calculator up again. And that gives us 131.8. So T1 is equal to 131.8 newtons. And the last one that we have to calculate is T3. Well, T3 is equal to mg. So T3 is equal to mg, which is equal to 15 times 9.8 newtons. So there are a lot of steps here. And there are a lot of places to make mistakes, so you need to work carefully through this. And if you follow these steps, analyzing the vectors, breaking them into components, adding the components, you can find the solution to some very complicated cable problems like this, but you do have to be careful. This one, what is the tension in the cable attached to a 5,000 kilogram elevator that starts on the ground floor at rest and accelerates upward, reaching a speed of 3 meters per second in 2 seconds? Okay, well, let's draw the free body diagram. That's always a good place to start. Well, the elevator has a mass, a weight of mg, 5,000 kilograms times 9.8. And then there's a cable pulling on the elevator. I'm just going to call that T for tension. Those are the only two forces acting on the elevator. So let's go ahead and write the Newton's second law equation that applies to this situation. And it's all in the y direction, so we'll do that. Sum of the forces in the y direction is equal to the mass of the elevator times the acceleration of the elevator in the y direction. And that's equal to forces up minus forces down. And we're looking for the tension. So I'm going to rearrange my equation here. Solving for the tension. Tension is equal to mass of the elevator times its acceleration plus mass of the elevator times the acceleration of gravity. I'm going to factor out the m. And this little equation here, while not something that you should memorize, is an equation that shows up frequently when we're talking about elevators. Well, we know the mass, that's 5,000 kilograms. We don't know the acceleration, but I think they gave us the information that we need to calculate that. So this becomes a kinematics question. We have a speed and we have a time. I'm going to fill out my kinematics form, and we have y0 is equal to 0 meters. Y, we don't know or care. We don't care where it ends up. The initial velocity in the y direction starts on the ground floor at rest, so that's 0. And after a period of time, it reaches a speed of 3 meters per second in the upward direction. And we're looking for the acceleration. And the time that this speed change took was 2 seconds. So we need an equation to find acceleration without knowing what the final position was. Well, that's our second equation. This is also the definition of acceleration expanded out. And the acceleration is 1.5 meters per second squared. We're going to bring that up and put it into our equation for the tension. And that's 56,500 newtons. 56,500 newtons. Our answer. Okay, let's look at what's up next. Oh, your free response question. Good luck. We'll see you in class.